All right, we're now going to work with this vertex form of the quadratic function or quadratic relationship, as well as the transformations of it. But the key is knowing this vertex form of the equation. So this is the vertex form of the equation. You need to know this. Like, this is a really important idea here. You need to know what that value of a, the thing in front of the brackets, what it does, which I've outlined, of course, which I also talked about in the previous video. The h we know is the x-coordinate of the vertex, but in also further to that, that also tells us the x value that we use for our equation of the axis. It's also, when we do the k represents the y-coordinate of the vertex. That y-coordinate of the vertex also tells us our optimal value there. So I'm going to add those things into this as well. So it's the h represents your x-coordinate of the vertex. It's also the x value for your axis of symmetry. And your k is your y-coordinate of the vertex, which then also is your optimal value. The a is what's going to tell you if it's a max or min value. So let's put these into play now with this example. So I've given you an equation. We want to find the direction of opening. The direction of opening comes from the a, and here is our value of a being -1. So since it's negative, it's opening down. To get our vertex, we're going to take x, take away, and then it's +5. We're taking away +5. So the x-coordinate of the vertex is +5, or just think whatever you have in the bracket with the x, you're switching the sign on it. So it's x, take away 5, make it +5 for the vertex, the x-coordinate of the vertex. The y-coordinate comes from here, it's +2, so your vertex is at 5, 2. Your axis of symmetry will be x equals 5. Your optimal value, because it's opening down, it's going to give us a maximum. So you should have max of, and then it's going to reach a high value of y at 2. So it's the y-coordinate of the vertex that we're looking at. Now, this is new here. Values that x may take. Now, because that parabola opens down on our x-axis, I'm just going to do a little sketch over here. You don't have to copy this down, but we've got a vertex at 5, 2. So here's my x-axis and my y-axis, 5 to the right and up 2, and then opening down. So something that looks like that. Now, as we continue that parabola on and on forever and ever in both directions, it's going to span more and more to the left and more to the right. The values of x that we're going to use will be all x values. It's x, all real numbers, all numbers you can think of. So all real numbers, that you can possibly think of. And we use the word real because there is another number system where we introduce complex numbers, which is very complex, but we don't talk about that in high school anymore. Another way to write all real numbers, and this is using mathematical symbols, which we'll get into in grade 11, is x belongs to the set of, so it looks like a curved capital letter E, and then we use a double stick on a capital letter R. So it says x belongs to the real number system. That double stick R is the real number. So either put all real numbers in words, or you could use x as an element of the reals. Now, as far as y goes, we only reach a maximum of 2 on the y-axis here, and we use all values below or equal to that 2. So when we're going to put our y values in here that we use, we're going to say y has to be less than or equal to 2. Okay, so if you understand that, try the next two. You can put the video on pause and try them. If you want to walk through it with me, that's fine, I'll walk through it as well. But you can always just skip through if you've got this when you do a check. All right, the next one, our a value is +2, so that's going to open up. The vertex, we're going to switch the sign here. It's a +3. The x-coordinate of the vertex is -3. We really have nothing being added on the end. You could have a +0 there. The y-coordinate of the vertex is a 0. Our equation of our axis should be x equals -3 then. It's opening up, so we're going to reach a minimum before we turn around and go back up. This will be a min of 0. Again, it's for all of these parabolas until we get to context, until we get to stories or problems with context or a story to go with it. our x value will be all real numbers. So I'll just put ditto here, the ditto marks, or you can put x as an element of the reals or all real numbers. For the y coordinate here, this parabola is at 0 on the y and then heading up from there, so our y will be greater than or equal to 0. The next and last example here, we've got a half, it's positive, so it's going to open up. We're adding nothing to the x before we square it, so the x-coordinate of the vertex is 0, the y-coordinate is -9. So whatever's attached to the x before you square it is the x-coordinate of the vertex. The number on the end will be the y-coordinate. Our axis of symmetry should be x equals 0. It's opening up, so it's a minimum, and the minimum value is -9 in this case. Our x is all real numbers, so I'm just putting the ditto marks there. And because it's opening up, it's going to be y is greater than or equal to, and then the y-coordinate of the vertex is -9. All right, so let's move on to transformation language here. State the transformations in order that occur to the graph of y equals x squared to get the graph in the given equation. So remember, every parabola, every quadratic can be expressed as a transformation of this parent quadratic. So if I look at this, I'm always going to do reflections and compressions or stretches first, and then I do my translations left, right, up, and down second, or after the vertical stretch or compressions and reflections. So kind of think left to right as long as it's written in that standard format, vertex format of a x minus h all squared plus k. So here we have a reflection in the x-axis. The 5, it's going to be +5 for our x-coordinate of the vertex. It's moved 5 to the right, and then we're going +2. It's moving up 2. Okay, so hopefully that makes sense there. Think left to right, stretches and compressions and reflections happen before the translations. Translation, if you want to use the word slide or shift, you can use those words instead of the word translation, if that makes more sense to you. All right, again, if you want to try, and I royally messed this up, if you want to try the next 2 examples on your own and then check the video, by all means you can do that. If not, just follow along with the video. Okay, looking at this second example here, we have the 2 out in front. That is positive, so it's still going to open up. We don't have that reflection in the x-axis, but what we have instead is that vertical stretch. It's going to make it skinnier. So we're going to say the first thing here is 1, a vertical stretch by a factor of 2. The second thing that we're going to have here comes from what's attached to the x, and when it's attached to the x in the bracket with the x, think switch the sign. So -3 would be the x-coordinate of the vertex, and so then it's moving to the left 3 units. And then we have nothing on the end. We could say it's +0. There's no vertical translation up or down on this one. Okay, and this last example, again, I've got something in front of that x squared term. It's a 1/2. So 1/2 is less than 1, but still positive. It's going to open up, so no reflection. But we have that compression by a factor of 1/2. There's nothing attached to the x before we square it, so that you can think of that part as being x take away 0 all squared. So we haven't moved left or right any, but we have slid down 9 units here. All right, so I've summarized those ideas. So hopefully that makes sense with stating transformations. So you should be able to state key characteristics from the equation as well as be able to describe it as a transformation of y equals x squared. The last thing we want to do is put all these pieces together to be able to solve problems and put it into context. And I think I'll start that on the third video for this lesson, just because of timing on this one.